So this question, we've got an arithmetic sequence. When it's an arithmetic sequence, that means we're adding on the same number each time to get from one term to the next. So for this sequence, we can see to get from 5 to 9, and then from 9 to 13, and so on, we're adding on 4 each time. That means it's very similar to our 4 times table, which would be the sequence 4n. So n is just the position in the sequence. So when n is 1, we would get a value of 4. When n is 2, we'd get a value of 8. But we can see that we actually want to have the sequence 5 and 9. So to get from my 4 times table to the sequence that I have, I need to add on 1 to every term. So therefore the nth term is going to be 4n plus 1. For part B, we're given the sequence 4n minus 5, and we're asked to find if 103 is a term of this sequence. Now that means that there's going to be some value of n, when I substitute it into my nth term, would give me a value of 103 if it's a term in the sequence. So the question really is there a value of n that makes this equation true? Now obviously, because n is a position in the sequence, n would have to be a whole number, so anything else wouldn't work. So we can go through and now solve this equation. We can add 5 to both sides and get that 4n would have to equal 108. We can then divide through by 4 and you get that n is equal to 27. Now that is a whole number. What that is actually telling us is that 103 is the 27th term in the sequence. Okay, so as a conclusion we can write yes, it is the 27th term. And this is really important to show that you're understanding what you're doing.